Hi, I'm Dave Robertson. I'm going to show you how I made this pick and rock statue with some 3D printing and the ages-old method of sand casting. I've made videos in the past where I talk about our use of low-cost additive manufacturing in the making of match plates here at the University of Texas at El Paso. It started about 6 years ago after I bought a Prusa at my house and started making this pick and shovel mold. And these picks and shovels, if you will, go on the graduation plaques of everyone that graduates from our department at the undergraduate, master's, and PhD level. Ended up printing each piece. At the time, my printer was housed on my dining room table, much to the chagrin of my wife. Ended up printing each piece. Then we kind of piecemeal the match plate together, and we glued the individual printed pieces onto a piece of wood. You can see I even was careful and put some datum points, if you will, to kind of mark where I needed to put the pieces. And then kind of continued the process until we had a complete match plate. This particular match plate was designed to make 4 picks and shovels at once, so kind of a mass production type of technique. Again, I've mentioned this in a previous video. Sand casting is probably the oldest mass production method known to humans, and dates to about 650 BC in China. One little feature I want to point out is we have these little notches here, and these notches fit into a flask, a metal flask, which has a top and a bottom. The bottom is the drag, the top is the cope. Always put a couple of coats of paint on my match plates. A lot of times I use something to fill in the defects. Auto body primer works pretty well. The match plate then fits in this metal flask. Again, there's 2 parts, a top and a bottom, cope and a drag. And we end up packing sand in it. So we pack both sides, and of course you want to remove the match plate before you pour the metal. This was the first product that we made in my department when we started integrating additive manufacturing into our mold making process. The pour is fairly dramatic. This is copper. The crucible is red hot, and the metal is molten. Molten red hot metal, very, very dramatic, very, very exciting to watch. For this video, I'm talking about all printed match plates, and instead of using a big metal flask, I'm using a smaller metal flask. I don't have a dimensional reference, but I do have my hand in the picture to kind of give you the idea that these are small metal flasks. I do believe the manufacturer intended this to be cast vertically, so you want to pour the metal here. I designed this mold to be cast more like the flasks I'm used to, so I'm casting horizontally. I don't know if you can see it very well in the picture, but I have these metal pegs here. There's 4 of them, and they're designed to fit in these holes. And so what I've done is I've made an all printed metal match plate, and it has holes in it that are designed to fit in these pegs. I need to give credit where credit's due. The designer, or the original designer of this pick and a rock, was my PhD student Truman, excuse me, sir, who's graduating with his PhD in MACE, Material Science Engineering, in December 2021. So I want to give some props to him and thank him for the original design. He designed it. It's actually a kind of a cool design in the spirit of UTEP. We're the miners, if you're not familiar with our university. It has a lot of kind of interesting detail. What I did was I ended up cutting his CAD file in half and then cutting a bottom so it'll be able to sit on a desk. I also added this little handle, and again, I'm printing a top and a bottom. The reason I'm printing a top and a bottom is because I did try, and I think I'll mention this again. I tried to print it as one whole part, but to do that, I would have had to print using support on one of the sides, and it actually hurt the resolution. So it was easier and actually lent itself to better quality to print a top and a bottom piece. So I just printed them one at a time, and I'll show a little bit of that in a little bit. This one is the top, and I have a riser and a little bit of a gate. And then I ended up using a pencil, and I'll mention this again later and show you pictures. I ended up using a pencil as a sprue. At the bottom, I put this little geometrical feature to kind of help the metal flow into the mold cavity. And I think you'll like the end product. I thought it was pretty cool. I have to apologize a little bit. The video footage and photographs I took for this video are made in a kind of a social media type format. So I took a lot of these pictures and posted them on Instagram, but I didn't do much footage in the widescreen format, which is why my video looks this way. Once I had the CAD drawing, 3D Builder lets you export into STL format and also .3mf. I've been using STL format for a lot of years, so I kind of keep to it. I imported that into a slicing software. The slicing software I've been using is Simplify 3D. You could also use Cura. I printed each side, so I printed them one side at a time on my trusty Prusa that I purchased in 2016 and built with my son. Again, I printed both sides one at a time rather than printing an entire object because one side would have had to have used support structure and it would have left it with a bad resolution. And actually, I did print it. I did try it that way in one print and I didn't get the resolution I wanted. Here's a photograph of the top side. So this top side has the riser and I then put the sprue on top of the riser, and you'll see later the sprue I used was kind of an oversized Ticonderoga pencil. These little holes here again were designed to fit in the pegs that are in that metal flask. And I then, my video here is showing both sides of it. So I glued it together, painted it, and this is after I removed it from the sand. And there I am melting my pewter. Here is the packing process. I started with the backside first. I coated it with baby powder, which nowadays is cornstarch, versus talcum, which I guess has been found to be carcinogenic. Then I flipped it over and started packing the other side. I'm using the oil bonded Petrobond sand and packing the top side. Again, I used just a pencil as my sprue. I then of course removed the sprue and also removed the match plate from between the cope and the drag. Here's the all-important pour. Not as dramatic as the molten metal aluminum or copper or bronze I usually do with a red hot molten crucible and red hot molten metal. This pewter I'm using is an R98 pewter. It's 98% tin, 0.5% bismuth, and 1.5% copper. It's pretty much becoming my favorite pewter. Here was the end product, but I have to admit my first try actually had a bad side. It had some air entrapped in it, and I'll show what that looked like here in a little bit. I was able to mitigate that problem by putting in, basically this is a little dowel rod about the size of the rod of a Q-tip onto the kind of the rocky part, and that was to allow the air to escape when I did the pour. After it comes out of the sand, I basically cut off the plumbing, so to speak, so the sprue, the riser, and the little runner here. And I did a little bit of a cleanup of the Dremel, but I wasn't able to get any footage of that. Here is the two, this was the first attempt, and so here you can see the air is entrapped in it. The second one came out a lot nicer. I had a little bit of a defect, but I kind of left it in there for character. I actually do like the print lines from the FDM type printing. I think it gives it a little bit of character. That's pretty much the end of the video. And it was a pretty simple process, as you may have guessed by the length of the video. I hope you enjoyed what you saw. If you like this video, please give it a like and feel free to subscribe to my channel. If you have any questions about what I do and what we do at the University of Texas at El Paso, feel free to email me. I have my email address in the credits. Thank you.